Hello everybody. So this is the Rocket Community Sync number 4. Let me share the slide. Okay. So last week we had new release, quite important release, Rocket 1.0. Do you want to take all of
Sure. Yeah, we're really excited to have 1.0 out. So 1.0 is where we're encouraging people to use Rocket in production. Even though we've already seen some use in production, now we're sort of standing by the command line interface and things like that. So yeah, very important release for us, but certainly not the end of the journey. Expect us to still see pretty regular releases over the coming months. I'm happy to answer any questions anyone has specifically about 1.0.
I will keep a look at the Google Doc on the agenda if people start to ask questions on that. And I just looked before at the statistic on GitHub for the Rocket project. We have so the development had been started 1 year ago, and we have a bit more than 100 contributors, and a lot of people have been forking the projects and liking it. Today we have several talks or demos. Talks, I think. Who would like to start?
We can start with Tom.
Is Tom here?
Maybe not. Maybe we should start with Sysdig.
Sure.
Okay.
This is Apurva. I'm here. Hello, everybody.
Hi.
Hello.
Give me just a moment here to share my screen.
Okay. I can
just confirming that you can.
Hey, Alvin, maybe you want
here.
to screen.
Just
Yes.
You can see my screen.
Yep, we can see it.
Yep.
Great. Okay. Thanks everybody for your time. My name is Apurva, and I'm with Sysdig.
You're a smart.
And Sysdig.
Oh, yeah. Sorry, Apurva, we're looking at the wrong window now.
Did it go away?
Well, you've got Slack.
Okay.
On that one.
There we go.
Oh. Guys, you don't want to see my Slack? Come on. It's amazing.
Not enough
Okay,
gear.
sorry about that. Hopefully that's gone now. Okay, I'll note that for next time. Okay, it actually seems like we have a really high latency. Try to pause between slides. Sysdig is we're all about monitoring and analytics for your container environment, and our kind of our specialty is fully containerized environments. We've built a product that we call monitoring as a microservice, and it slots in. Our agent actually slots in as a container in your environment, and without any instrumentation of the containers themselves or the underlying guest hosts, you can understand everything that's going on from your application all the way down to your infrastructure. We do this as special kernel driver that we created, and we can kind of hook into the kernel and see all the system calls that are taking place underneath all of your containers. We're a system that supports all different container environments, and of course we're really excited to support Rocket in our most recent release, which we did in concert with CoreOS releasing 1.0. And with this kernel driver in place and our instrumentation, we can do a couple things. As I'll show you, we can do real-time monitoring and analysis of your entire environment. We can allow you to do trace captures of Rocket environments so that you can save trace files and analyze them later. And we will do this in two different ways. We have an open source command line driven tool that we just call sysdig, and that allows you to see everything on an individual host and basically perform everything I was just talking about on an individual host. And we have Sysdig Cloud, which is a commercial solution, and it's designed for distributed monitoring. So where you've got tens, hundreds, thousands of Rocket containers running over different machines in different data centers, this is probably the right tool for you. So again, we really are interested in helping Rocket perform well in production. And our belief is that as the container ecosystem matures, one of the core elements that enables it to go to production is high quality visibility and monitoring that exceeds the last generation's tools. So I just wanted to give you a quick flavor of what these products look like. And so let's start with the open source product. There are actually two flavors of it, Sysdig and C-Sysdig. Sysdig is a CLI tool, and C-Sysdig is an Ncurse's UI-based tool that provides you a little more interaction, but still in a kind of command line format. And you can kind of see anything that's going on in a host here. You'd expect to see is resource utilization. What's more interesting is that with our command line tool, you can see all network and file activity, and you can see all system calls that any container is making. So basically, if a container is calling out to underlying resources or to another container, we can see it. Incredible capability to understand what your system is doing and troubleshoot problems. As I mentioned, Sysdig Cloud is designed to be cross-host, cross-cloud. It gives you a UI-driven monitoring of your environment as well as trace-driven troubleshooting. And there's a couple cool things about it that we think is that's interesting and different. Is first of all, basically it acts like a big database of your infrastructure, and you can interactively drill down into anything from a microservice all the way down into the individual container itself. You can see your typical resource utilization, and you can see what's going on inside your containers as well. So this view is something that's pretty straightforward, which is like showing you your Rocket containers and what type of resources they're utilizing right now. You could easily group that information into something that's showing you app level visibility. So this one, the response time of your web application, that of course is living in a Rocket container. And you can start to do things like see what types of requests that's handling, what are the slowest URLs, and what are the top URLs that people are accessing. So it kind of gives you a blend between your typical monitoring plus a layer of service-oriented performance management to understand what's going on. One last thing here, which we always get really excited about, it's actually looking at the topology of your deployment. And so this is a really great way of seeing the topology of Rocket containers communicating to each other. And again, you could do this on the container level, you could do this at a service level, so that you can kind of understand who's talking to who, and where the left hand and the right hand are pointing. It's a really powerful way to troubleshoot resource utilization, network activity, and request activity. So we just love you to get started with the product and see what you think. The open source product, you can find it at sysdig.org, and the commercial product at sysdig.com. And you definitely can ask us any questions. We'd love to help you along the way. And that's it for me. So if you do have any questions right now, I'd be happy to take them. Or hold it to the end, depending on what, Alban, how you'd like to handle it.
If people want to ask questions here or on the Google Doc, then...
Actually, I have a question. Is that okay?
Yeah.
The kernel module, I saw in your GitHub repo, part of that is open. Is that truly open source, or is that proprietary?
Yeah, so the kernel module is open source. It's part of the core open source product, and actually we're working with the Linux Foundation to just get it packaged up with Right now, a couple operating systems actually package up sysdig with it, so you kind of get that, kind of get some level of support. But we'd like to go all the way and have it just built into Linux. So we're, hopefully a couple months away from that.
Okay, thanks.
I have a question too. So you mentioned it can see sort of inside Rocket containers and look at app level performance.
Yes.
So it can sort of split out within a pod like how the different apps are performing.
Yeah, so that's kind of part of our cool technology, is that running at the kernel level, we see every single system call, and then we can map those system calls to what we typically expect from particular applications. So that gives us the ability then to present a view where we can see, well, our particular database queries running slower than others or something to that effect. And the real beauty of it, you can instrument and monitor your whole system without having to deal with any plugins of any sort. So if your developers start to release new code that maybe you weren't aware of, or they have a new infrastructure component, then sysdig basically can see that, automatically detects it, and level checks.
Is that heuristic based?
Yes.
Okay.
So we have some basic heuristics that help us understand what applications typically do, which means that as in order to support more and more apps, that sysdig does the work to go see what those heuristics look like and kind of establish the check. And then we have an open way for you to build your own checks if you'd like.
Cool.
Thanks, everybody.
Thanks.
Thank you.
Yeah, thanks.
Maybe Tom is ready for
I'm
another
here now. Yeah. Can you guys hear me okay?
Yep. Yes.
Cool. And can you see a screen web page with a couple of terminals? Hope so. So I'm an engineer on Calico, Project Calico, and we are a pure layer 3 approach to networking. We've had a CNI plugin for a few months now, I think, a couple of months. Initially focused on using that with Kubernetes, and now with the Rocket 1.0 launch, we've got a guide for for using that with Rocket. So I'm going to demo using Calico with Rocket and CNI. So we have this guide that uses Vagrant to set up a couple of CoreOS servers. So our Vagrant file is super simple. Just have a couple of instances using the latest CoreOS alpha from this week, so that we get Rocket 1.0. And then we just have a cloud config for the first server, a master cloud config, and a node config for all of the other servers. And that cloud config is also pretty simple. So we set up etcd, and then we have this service to download Calico. And there's two mainly relevant bits in there. So we're setting up some paths, and then downloading the Calico Cuttle helper program, and then the Calico CNI plugin. And the node config is identical, but just has an etcd proxy rather than a master. So we have this guide in our GitHub, and it just walks through using Vagrant to create these servers. So I've run my Vagrant up already. I've got a couple of servers up. So the first step is to use the Calico Cuttle program to run the Calico agent on both the servers. And this is using systemd run to create a transient unit file to run Rocket, to run the various Calico components. So they can all be checked using Journal Cuttle or System Cuttle. or the Calico Cuttle status command can show us that the two servers can see each other, and they've set up a BGP mesh to exchange routes between the two servers. So Rocket uses CNI, which lets us create networks. So I'm going to create two different networks by dumping these config files on both hosts. So I have a network called Net1, another one called Net2, and they're both using Calico as the network type, and the Calico IPAM as the IPAM plugin. So using that network, I'm going to run an Nginx container on my first host using systemd run again. So that is passing in this --net equals net1 option to put the Nginx container on the net1 network. So that should now be running. So I can do a rocket list and see that I've got the Calico node component running, and I've got Nginx running as well. And that's been assigned an IP on net1 of 192.168.0.0. So from my second host, I should be able to run another container, also putting that on net1, running a BusyBox container, and just running a wget that's going to try and request from that IP address. So if I run that, I should hopefully see the hello world from Nginx. Oh no. Yes, phew. So I've got the welcome to Nginx response. So my second host has pulled that from the first, and I can run the same command. Run the same command on the first host. Okay, and so because I created two different networks, there's isolation between those two networks. So if I run a BusyBox container running wget, but trying to retrieve from that IP address, but I put the container on net2, then I should see that the download times out and it's not able to contact it. So yeah, download timed out. So that's all I wanted to demo. It's all covered in that guide, so try it out yourselves. And if you want to learn more about Project Calico, you can look at our GitHub or projectcalico.org website. And anyone has any questions, I'm happy to answer them.
So you can either ask the questions on the chat or in the document. If you have any.
I have a question. Can you hear me?
Okay.
Okay. Tom?
Yep.
Why are you using this weird IP address for the host? Do you have a reason for that?
It's a good question. Because we can, because we know everything that's on that network. So I don't know. There's been much debate about whether we should use that IP address because it looks weird to people, but there's nothing wrong with using that IP address. It's just an IP like any other IP. It's just convention that it's weird.
Okay.
But yeah, nothing special about it. We just start allocating from 0.
How do you allocate?
So we have our own CNI IPAM plugin, and Calico uses etcd for its coordination. So we're using etcd to help with the allocation, to help with the locking. And then I think this allocation strategy is just sequential, and we currently reserve blocks of 64 addresses per host. So we have some kind of host affinity, which just helps with the BGP routing.
Okay. What do you do with containers that never clean themselves up? How do you handle that with the allocation?
So we're not currently expiring the allocations or running any kind of garbage collector. So we have plugins for not just Rocket, but LibNetwork and OpenStack and various other things. So we're normally relying on the orchestrator to ensure that containers get cleaned up. And if they don't, then you have to manually go in and clean up those allocations.
Okay. Have you ever run into the problem of running out of IPs?
No, not that I'm aware of.
Okay.
I mean, it's all just private address space, so there's no shortage.
Yeah. Okay, thanks.
Thank you as well. Can you see me? No. Yeah, I wanted to talk a bit about traffic control in containers. So there is nothing to show really. I don't have a slide, but I was thinking that Rocket is used a lot in the cloud, but less use case for running on the developer's laptop for development. And for some use case, I was thinking of if you have several containers and we want to apply some specific network condition like low bandwidth or high packet drop or bad networks, it will be useful to apply some traffic control for testing purpose. And to do that, I run on my laptop RTP, RTSP media server, and but I don't know if I can share everything. I will try.
Screen.
Screen share. Can I click on all the windows?
In the top left, entire screen.
Entire screen. So let's try that. Okay. So here I have a video player running on my laptop. It's connected to this IP address, which is a redirection to a Rocket pod where a media server is running. On the demo effect, I guess. It doesn't seem to display anything anymore.
Is your container?
Let's see if it works. No? Okay. So I will skip the demo. So what I wanted to demo is to have I will still show you the UI. If I can. So I have a very simple UI where I can define some network properties, like some packet loss, and if I say that 5% of packets should be dropped, then the quality of my video is going to drop. And I was hoping to show that. How it's done in the demo is not integrated with CNI, but I wanted to add some CNI plugin for traffic control, where testing framework could dynamically change the network properties. So if the testing scenario says, okay, it works fine at the beginning, and then after 30 seconds, there are a lot of packet drop, I could test something like that. So if developers have applications like a media server or other applications, I was thinking of using Rocket and CNI as a way to test the applications.
Yeah, the demo is actually in the Kinfolk GitHub account under demo repository.
Yeah, so I added a link in the Hangout.
Okay, yeah, we'll have a blog post about that really soon.
Okay, I'm done with this. Stefan, do you want to talk about IPv6 status? What's
Yeah, I can say a couple of things. The official state is that we do not support it, which is a bad thing, in my opinion. Where I see a use case is for having containers or pods exposed on the internet instead of doing all the traffic forwarding or port forwarding, because we have so many IPv6 addresses that it shouldn't be a problem. But for that, we have to support it on every layer. So it starts with your container cluster manager, which would be Kubernetes or something else. Then CNI, all the CNI plugins have to support it. And in Rocket, we have many places where we have to introduce the distinguishment. So it's going to be a lot of work. And I would love to see people helping if they have network knowledge and can do some Go coding. You're all invited to help in CNI and Rocket.
Where's a good place to get started with this stuff?
Typically on the bottom. So CNI is the thing that has no dependencies. So I would start with CNI and then work the way up to Rocket. And eventually whatever cluster or container manager people are using. So the first thing will be integrating it in CNI.
Okay. Great. Anything else to say on that?
Nope.
No. Not wanted.
That's all.
I thought you were going to give a demo.
Yeah, I thought you were going to have it all done for us.
It works. It's just not supported. You can actually see on the CNI documentation pages that some examples with IPv6 are given. The funny thing is that the code doesn't know it's an IPv6. It just handles it on accident. So you can't really be sure that all the features are going to be working. But I tested it on a bridge to my local network, which was also exposed to the internet, and it was actually working. But it's not done right. But there's also a lot of trouble with the netlink package and also the official net packages by Go. The simplest things like 2 IPv4 and 2 IPv6 methods, they don't work properly. So you can't even rely on those. You have to still do the parsing manually. So there's a lot of places to work on.
Okay.
Tom, do you currently handle IPv6?
Yeah, Calico has no problem with IPv6. I'm trying to remember, like, I'm pretty sure for Kubernetes, the CNI plugin is always expecting us to provide an IPv6 address. So our IPAM is actually allocating IPv6 addresses as well and somehow returning them to Kubernetes, but I can't remember exactly how that works. But yeah, we'd definitely be interested in helping to get IPv6 support to be supported in CNI.
Yeah. Another thing would be if you have an allocator that already uses etcd, that is something that I thought about for CNI. I recently opened an issue to decouple the IPAM plugin, so we could exchange the backend and exchange the allocator. Basically, we could add, we could steal the code from Calico, integrate it as an etcd backend.
Yeah, that'd be interesting.
So you could just use the etcd store with whatever allocator you have.
Yeah, definitely sounds interesting. The Calico code is written in Python, not in Go, so that might present some extra interest. But
okay.
Looks interesting.
I mean, there's also the flannel code for doing some amount of IP allocation in Go with etcd as a backend, so that might also be interesting to look at.
Mm-hmm.
This code.
I really see CNI as a common place where we store all the routines that we need, because eventually you're going to have executables and you don't really depend on Go. So it will be interesting for everyone.
Mm-hmm.
Okay, thank you.
Thanks. Yeah, the last slide was to suggest the next date for the next community sync in 2 weeks from now. Great, and that's all.
Well, that's all we have for today, but if anyone has any questions, we can certainly open it up to the floor.
I'm checking at the Google Doc. No questions so far. So thank you.
All right, thanks everyone.